So this video is going to be talking about relations, functions, and direct variation. So there's different ways to write relations. So it's going to be a set of input and output values. Input is always going to be your x values. Output is always going to be your y values. So you can write it as ordered pairs, like this. You can write it as mapping, so the arrows go to the point. So we got -3 going to 2, so the point is -3, 2. You got 1 going to 4, so the point is 1, 4. 5 going to 6, so the point is 5, 6. You could have a table with input and output values, these representing your x's, these representing your y's, and then you could also graph the points. Domain and range. Domain is always your x values, range is always your y values. So we could do domain, 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 and then range is all your y's. So range, 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 range. Okay, so I'm going to write these as points. -3 is going to -2. I have 0 going to 7, and I have 4 going to 1. So if we're trying to tell, this is function, if we're trying to tell whether it's a function or not, you're looking to see if your domain repeats with one range, or doesn't repeat. Okay, so it only should match with one range. So if you look, domain should be all of your x's. So you're trying to see if your x values repeat. If they don't repeat, then yes, it is a function. If your x's repeat, then no, it is not a function. And you'll see why when we graph them. Okay, so we're going to check this one. So we have 2 going to -3, 2 going to 3, 3 going to -1, 4 going to 3, and 6 going to 6. So in this, we have them repeating, so no, this is not a function. We don't care about the range or the y values. We are only looking at the x values. Vertical line test. So determine whether something is a function. Okay, so if I have, let's say, this picture, we're doing a bunch of vertical lines to make sure it only crosses once, or to show that your x value should only have 1 in that spot. So you can see that they're only crossing my graph once, so yes, this is a function. Okay, if we have this and it crosses twice, that means your x values are repeating. So no, it does not cross it crosses the vertical line test twice, so no, it is not a function. So it does not pass my vertical line test, because my x values would repeat if I had all of those points. Okay, an equation that represents, we're talking about the function rule. There we go. Function rule, an equation that represents an output value in terms of an input value. You can write it in function notation. So it's basically when you have this f of x here. Okay, and we're going to be plugging input values in, so x values in, to find our output value or our y values. So if I have f of x equaling -2x plus 5, trying to find my output, so I'm putting in my input, so I'm putting in x values. So my first one is -3, so I take x out, with parentheses I put in -3, -2 times -3 is +6, 6 plus 5 is 11. Okay, here's the deal, we're talking about function notation, so I'm not dividing this by -3. It's talking about the function of -3 is going to be 11. So if I wanted to write the point, the input value or x value I put in was -3, the output value or y value I got out was 11. Okay, this is just talking about function notation, not f times -3, so do not divide by -3. Oops, let's do the other ones, I guess. F of 0 equals -2 times 0 plus 5, so -2 times 0 is 0, 0 plus 5 is 5. So my function of 0 is 5, so my point is 0, 5, because I plugged in 0 as the input or x value. My output that I got out, or my y value, was 5. My last one is 1. -2 times 1 is -2. -2 plus 5 is 3. So the function of 1 is 3, so that point then is 1, 3. State the domain and range and tell whether it's a function. So remember, it's domain, then range, 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 domain, then range. To tell whether it's a function, you look to see if your x values repeat. They do not repeat in this one, so yes, it is a function. It would pass my vertical line test. This one, the -1s repeat, so no, it is not a function. It would not pass my vertical line test. Okay, this time we have x representing -7, so f of -7 is equal to -5, in parentheses, -7 minus 3. So we should get a positive 35 minus 3, which is 32. So f of negative 7 is 32. The point is negative 7, 32. Is this a function? We do a vertical line test. It crosses twice. So no. If I do a bunch of vertical lines, they only cross once. So yes, it is a function. Okay, direct variation. So the function of y equals kx, or you could write it y over x is equal to k, and k is going to be your constant of variation. So this is very similar to your y equals mx plus b. Okay, so in some of these equations, we're trying to find the direct variation, so what they have in common. So kind of like if we graph the points, what the slope would be, what they would be increasing by every time. So in this, if I'm asking for the constant of variation, we're always going to be looking at the slope to see what they're increasing by, what the constant is that they're increasing by. Okay, so in this, we need to do our y over x equation. So if I do my y over x, I get 2 over 1, which is 2. I get 6 over 3, which is 2. I get 8 over 4, which is 2. So this, what they're increasing by, or kind of like what the slope is going to be 2. So the constant of variation this time is 2. My next one, I got 4 over 1, which is 4. I have 8 over 2, which is 4. I have 11 over 3, which is not 4. So there is no constant of variation because they're not increasing by the same thing. So if I graph them, there's not going to create a straight line because they're not increasing by the same number. Okay, we're identifying the direct variation, constant variation, okay? So I said we're relating it to the y equals mx plus b. So I need to get it into y equals mx plus b. So we're going to divide by 3 to get 7 over 3 x, and I said it was related to the slope. Your constant of variation is always the slope. So 7 over 3 is my constant of variation. Okay, this one I divide everything by 7, so I get y equals 2x plus 1, so my constant of variation this time is 2. This one I need to subtract 5x to get 3y is equal to negative 5x. Divide by 3. So my constant of variation this time is negative 5 over 3. This one is a little tricky because there's a 1 in front of it and the 9 is on the bottom. So the number that it is for my constant of variation is 1/9. So be careful of the fractions. Okay, suppose y varies directly with x and y equals 9 when x equals negative 15. What is y when x is equal to 21? So I want to find the y value that's going to make their constant of variation the same. So here is my first set. I got 9 and negative 15. And then my second set, I don't know what y is, but I know that x is 21. So we're trying to figure out the y value that would match it. Okay, so we're doing our y over x again because that's what we were doing when we were trying to find the constant of variation that was the same. So I'm going to do my set that I know. So y is 9 over negative 15 is equal to, I don't know my y, but I know this is 21, my x value. So we're going to cross multiply here. So I'm going to get 9 times 21 is equal to negative 15 times y. 9 times 21 is 189. And we still got negative 15y. Divide by negative 15. So y is equal to negative 12.6. So that is the y value that's going to make them have the same constant variation. Okay, this one I have my y, my x. I still don't know what y is, but I know that it's going to match with 12. Okay, so I have my y over my other given x is equal to, don't know my y, but I know this x is 12. Cross multiply, so I get 12 times 15. We drop the equal sign into the center. And 3 times y. So this time 12 times 15, I got 180 equals 3y. Divide by 3. So this time my y is equal to 60. So they would have the same constant of variation when my y is equal to 60.